This conference will now be recorded.
So today let us start off with one more new topic, multi-threading. Now, the meaning of multitasking is like opening multiple applications simultaneously. Like in my case, I have opened a browser, Notepad, GoToMeeting, Eclipse like this. If you are typing a document in Microsoft Word and you are listening to the song simultaneously, so multiple applications are running. That we call multitasking. Then what is a thread is like? If you take Gmail, in Gmail, how many compose windows we can open? Multiple, right? In Gmail, we can open multiple compose windows. This is one compose message. This is one more compose message. So every compose message we are opening in Gmail, since we are able to open multiple, this is what your thread here. This is what here a thread. This is a thread here. Now, in this compose message, how many attachments we can do? Multiple. So we can attach attachment 1, attachment 2, like this. When attachments are going on, I can type the subject and body of the message. So these attachments are also what? Thread here. So I need not wait, one thing should get completed. I need not wait, one thing should get completed. See, when you take Gmail, Gmail is what here? It is a task. In this task, how many compose windows we can open? Multiple. Every compose window what we open, they are what here? Threads here. They are threads. And in one compose message, we can go with multiple attachments. So every attachment is also thread here. And when attachments are going on, we can even type the subject and body of the message. And since these threads are part of this thread, we call it as thread group. The meaning of thread group is collection of threads. And what is the advantage of going with multi-threading? To increase performance. I need not wait, one thing should get completed. So to increase performance, we go for this multi-threading. How to define a thread is like, a thread is a lightweight process under execution within a process. So if you take Gmail as process, it's a task. And what are lightweight process? The compose message attachments comes under this lightweight process. And the advantage of going with threads is like, multi-threading is used to increase the performance of application. So one more good example is like our GoToMeeting. In this GoToMeeting, it's a task. I can show the screen. It's a thread. It's a thread. I can record the class. It's a thread. I can speak with you. It's a thread. All the things that we are able to do simultaneously. So this GoToMeeting is also multi-threaded. Now, let me take one more simple example to understand more of these threads. So when you run a Java program, it goes to main method. In this main method, we want to find sum of even. So to find sum of even, we are calling a method sum even method. Then here we go with one more sum odd. So here we define the methods sum even, where we go with some logic to find the sum of even numbers. Again we define sum odd, where we go with the logic to find the sum of odd numbers. Right? Now, when we run the program, it goes to main method. From main method, whenever we invoke SumEven method, the control will jump to this method. The control will jump to this method, and when the total method is completed by CPU, then only the control will go back to main method. Again, when you call SumMod, the control will jump to SumMod method, and when the total method is executed by CPU, then only the control will go back to the main method. Means in the case of traditional programming, in the case of ordinary programming, whenever we invoke a method, the control will jump to the method, and until the total method is completed, CPU will not come out. Let us suppose CPU is executing SumEven method. In between, CPU may be free. So when CPU is free, when you are doing some input-output operations, the CPU will be free. So even though the CPU is free, it won't allocate time to other methods. It has to sit idle only. In the case of multithreading, in the case of ordinary programming, whenever we invoke a method, so until the total method is executed, CPU will not give chance to other methods. CPU will not give chance to other methods. So in this case, when we invoke SumEven, the control will jump to SumEven method, and when the total method is completed, then only the control will come out. Then when it invokes SumMod, it will jump to the SumMod method, and when the total method is completed, then only it's going to come out of the method. In the case of ordinary programming, even though the CPU is free, it won't allocate time to other methods. This means we are wasting the time of CPU. If you make use of threads, if you make SumEven as one thread and SumMod as one thread, then when SumEven method is getting executed by CPU, in between it can even come out and allocate time to SumMod. So when you are using threads, your CPU is going to allocate some time for main method, some time for SumEven, some time for SumMod, some time for main, some time for SumEven, some time for SumMod. So in the case of multithreading, CPU won't sit idle. So when CPU is not sitting idle, then it's going to increase what? The performance of application. So that only we have to learn how to create threads in Java. So this is the basic introduction. Like the main need of going with multithreading is to increase the performance of our applications. Now let us understand how to create threads in Java. Creating threads. So whenever we want to create threads in Java, we are in two ways. That is by creating a class which extends thread class, or by creating a class which implements runnable interface. We are having two ways of creating threads. That is by creating a class which extends thread class, or by creating a class which implements runnable interface. Today we'll see about thread class, and in tomorrow's class we'll go with runnable interface. Let us initially see using thread class. Just we have to create a class, some class name like my thread extends thread. Now understand carefully. This thread class is a concrete class. Thread is a concrete class. Means fully implemented, not abstract. Okay, means opposite of abstract class only we call concrete class. Now, if a class extends concrete class, Do we need to override any methods compulsory? No. Only when you extend abstract class or implements interface, we need to override the abstract methods. But since we are extending concrete class does not have any abstract methods. No need to override any method here compulsory. But as a programmer, we need to override a method, that is run method. We need to override run method. And here we go with the logic of your method. Like you can even call other methods like some even, some not like this. Now, how to invoke this run method is, we have to create object of my thread. We have to create object of my thread class, and we have to invoke run method only by using start. So only when you say t.start, the object will become thread, and internally it is going to invoke run method. So creates a thread and invokes run method. So whenever we say start, the object will become thread, then it's going to internally invoke run method. So without start, no concept of multithreading. So when you say t.run, it will become ordinary program. So that I'll show everything practically to you. When you say t.start, what will happen? When you say t.run, what will happen? So any questions, anyone up to here? No. Let us understand one important diagram. State transition diagram of a thread. State transition diagram of a thread. A thread undergoes totally 4 states. A thread undergoes totally 4 states. They are new, runnable, dead, and blocked. New state, runnable, blocked, and dead. When can we say a thread is in new state is whenever we create object of your thread class like this. My thread t equal to new my thread. So whenever we create object of thread class, the object will become new state. Then when it goes to runnable state is when we invoke the start method. When we invoke start method, the thread will go to runnable state. Now, very important point to remember. Whenever we say start, the thread will go to runnable state. Don't assume that it will go to run method immediately. It is going to invoke run compulsory, but at what time it is going to invoke run, that is not in the hands of programmer. Our work is only to push the threads into runnable state. Then whenever CPU allocates time, then it's going to invoke run method of your respective thread here. Okay, so runnable state is like ready to run, waiting for CPU time. So to so optionally, here we go with running state. Here we go with running state. And it enters into run method internally. So when it enters into run method, it indicates the thread is running. So simple words to remember. Whenever we say start, don't assume that it is going to invoke run method immediately. It's going to invoke run compulsory, but at what time it's going to invoke run, that is not in the hands of programmer. Then I'll show this part practically. The next one, blocked state. When the thread goes to block state is when your thread is doing some IO operations, input output operations. Means reading some value from keyboard or displaying something on screen that we call input IO operations, input output operations. Or when we call the method sleep. If you say sleep of 1000 means for 1000 milliseconds, means for 1 second, the thread will go to blocked state. Or when we use the method wait, when we invoke the method wait, then also the threads will go to block state. When it comes from blocked state to runnable, when it will come back is after completion of IO operations. After IO operations, after sleep means once the time is completed, it automatically goes back to runnable. When we use wait, we have to use the methods notify or notify all. So more about this blocked state we'll discuss in tomorrow's class. We are having one more dead state from wherever it may be. We can terminate a thread by using stop method. Right? So we'll be understanding more of this diagram in today's class and next class tomorrow. Now, let us move to the next one. Methods of thread class. Methods of thread class. So it goes with the methods like thread current thread. The use of current thread method is it's going to return the current details of thread which is running in CPU. Then it's going to have the method like start. Start internally invokes run method. Then set name to change the name of the thread which takes string as argument. String get name which returns the name of the thread. Void set priority. Priority means importance. So when we give more priority, your CPU will allocate more time for our thread. Less priority means less time. Okay. Get priority which returns the priority of your thread. Then string to string method. So to string method belongs to which class? Object class, and this method is overridden in thread class. Then sleep method like this. Sleep method takes long as argument. Now let us discuss all these methods except sleep. Sleep will be discussing in tomorrow's class. Let us go with the program. Thread methods demo. So this program is mainly to elaborate about the methods of thread class. So from this program, we'll get a basic idea on threads. And in tomorrow's class, we'll get full idea on threads. How multithread is working. That we'll understand more in tomorrow's class with some other examples. Now let us go with this method, this code. So to store thread related programs, let me create a new package, threads package. In this package, create a new class, thread methods demo with main method. So this program is mainly to go with the understanding of methods of thread class. Now in this, let us create a class, my thread extends thread. Method extends thread. Now see, thread is concrete class. Thread is what? Concrete class. So we need not override any methods compulsory. That's the reason we are not getting any error here. But as a programmer, we have to override which method? Run method. Now let us go with some message like I am a thread. Now how to invoke this run method? In main thread, main is also thread here. So whenever we run the program, the first thread what it creates is main. In this main thread, let us create object of main thread. Once we create object of main thread, we have to invoke run method only by using start. So when you say start, what it's going to happen? Creates a thread and invokes run method. So to confirm that this start is invoking run, if you are getting this message in console when we run the program, this indicates start is internally invoking run method. So here let us run and check. See, we are getting the message I'm a thread. So with this, this confirmed that start is going to internally invoke run method. Clear this code? Any questions? No. Let us understand the methods of thread class. Let us go with the first one. Thread t equal to thread dot current thread. Thread t equal to thread dot current thread. So whenever we invoke the method current thread, it's going to return the current details of thread, like the name of the thread, priority, and thread group. So here, when you print the object, see the result what we are going to get. See here, it's saying see thread. See what is this hash 29? That is the number given to the thread number. So whenever we create a thread number will be given. So hash 29 is the thread number. Thread -0, it is the name of the thread. So whenever we say t.start, a new thread will be created. And what is the name it is going to give? Thread-0. So if you are creating one more thread object like t1, then if you are creating t1, then what's the name it's going to give? Thread-1. If you are creating one more thread t2, what's the name it's going to give? Thread-2. Like that it continues. Like now. And what is this 5? It's a thread priority and main is the thread group. So whenever we run the program, the first thread what it creates is main. Inside we are creating subthreads. So the main thread is called as thread group. Now let us create one more thread class object. Understand carefully now. My thread t1 equal to new my thread. Now if you say t1 dot start. So now understand carefully. In this program, how many threads are there in runnable? In runnable state, how many threads are there? Main thread, then T. What's the name given to T thread? Thread-0. Then T1. What's the name given to T1? Thread-1. Now, to avoid confusion, let me remove this main thread. Now, let us consider we are having T and T1 threads here. Now, when you run the program, which thread will execute first now? When you run this program, which thread will execute first? Okay. T or T1? See here, when you run, so which thread is executing first? T1. Even though we have created T thread first, but it is executing T1. Now let me run the code again. Now say it is going to T. Now T only. Again T1. T on. T1. T. So can you guarantee which thread will execute first? No guarantee. That is the point what I was mentioning. So our work is to push the threads into runnable state. So we'll just push the threads T and T1, T2 like this. Then for which thread your CPU is going to allocate time, that is not in the hands of programmer. That is the point what I was mentioning about runnable state. Clear this point, all of you? Any questions? No. Instead of start, let us go with run. We are invoking run method. Now in this program, how many threads are there? See here, only one thread main. Only one thread is main here. So this is not at all multi-thread program. And what is the number given to the thread? See 1. Because when you run the program, the first thread what it creates is main here. So when you say t.run, it will go to run method. Until total run is over, control will not come out at all. When you say t1.run, it will go to run. Until total run is over, it won't come out at all. It's an ordinary program. So we have to create a thread only by using start method. Without start, no concept of threads. Right? Now, so the main objective is to understand methods. So let us remove this part. So when you run, what is the output we are getting? This is the output what we are getting. So it's saying that it's a thread. This is the number of your thread. Thread -0 is the name, 5 priority, and main is the thread group. So who is taking care of printing this output in this format? Who is taking care? ToString method. So whenever we print objects in SOP, which method gets invoked implicitly? ToString method. So this ToString method of thread class is going to take care of printing the output in this format. Let us understand this output more. In this, hash 29 is the thread number or thread ID, you can say anything. The thread -0, it is the name of the thread. Main, sorry, this one, 5 is the thread priority, and main is the thread group. Thread group means collection of threads. Now, let us understand more in depth of this. When you take this multithreading, the topmost interface under multithreading is interface runnable. In runnable interface, it goes with one abstract method, run. It contains one abstract method, run. Then your class thread, I'm writing all internal code. The class thread implements runnable interface. The class thread already implements runnable. So when a class implements an interface, we need to override this method. So this run method has been overridden in thread class, but it's an empty method, no code inside. It's an empty method. Only to follow the rule of interfaces, the method has been overridden. It goes with other methods like start method. So whenever we invoke start, it makes your object as thread and internally invokes run method. And it even goes with other methods. So what I have listed above. These all methods are present in thread class. In this thread class, it goes with 3 final variables. Public static final, int min priority. So the minimum priority value is 1. Public static final, int norm priority. Normal priority is 5. public static final int max priority. Max priority is 10. Meaning for a thread, we can give priority between 1 to 10 only. And whenever we create a new thread, it is going to give which priority? 5. That's the reason it's giving priority 5 here. So it knows that it has to give 5 priority. It will come to thread class and takes its normal priority value, and that is given over here. Okay. Now, one more small question. This thread class belongs to which package? Thread class belongs to which package?
Threads package.
Not thread package. This my thread belongs to this threads package. This thread is predefined class, right? It's a predefined, and this is our user defined package. So whenever we use a class or interface without writing import statement, the class or interface belongs to which package? Already we discussed. Which package will get imported implicitly?
Java.util.
Not util.
Lang.
LAN package. Which package will get imported implicitly? LAN package. See here, this thread class belongs to which package? See, java.lan package. Java.lan package. So if you are using any predefined class or interface without writing import statement, the blind rule is the class or interface belongs to java.lan package. Now I want to see the profile of this class, the API. Means just what you have to do, just keep mouse pointer on this thread class, press Ctrl key, and you can see the option C, open declaration. If you click here, the complete document will get opened. See here, the class thread implements runnable, and see the package name. Here it belongs to java.lan package. Here the class thread implements runnable, and it goes with the final variables. Here min priority, normal priority, and max priority, right? Now let us understand the remaining methods. So by default, the name what it is giving, thread-0. Now we want to change the name. How to change the name? T.setName. We are going with the name thread, my thread. Now if you print T object, the output will be thread # name. The name of the thread is my thread, priority 5, and thread group main. If you want to pull out only the name of the thread, we'll call the method T.getName. So when you say T.getName, it's going to return the name of the thread, my thread. Then now we want to change the priority. Then we'll say T.set priority 8. Now if you print T object, the result is thread, the number, the name, my thread, priority now 8, thread group 8. If you want to pull out only priority of your thread, we'll say T.get priority, which returns 8 for us. Now so when we run, same output what I have given in comments. So any questions, anyone? No. If I give priority as 18, but just now we discussed for a thread we can have priority between 1 to 10 only. But when you are giving 18, is it showing any compile time error? No. Now let us run and check. When you run, we get an exception, illegal argument exception. So what is a very, very important point? If the priority is less than 1 or greater than 10, then it will throw illegal argument exception. Right? Very important interview question. If the priority is less than 1 or greater than 10, then it will throw illegal argument exception. Now, this illegal argument exception, is it a checked exception or unchecked exception?
Unchecked.
Checked or unchecked? Very good. It is unchecked because we are getting runtime error, right? So if you are getting runtime exception means during runtime, if you are getting error means unchecked. Then this illegal argument exception is a subclass of which class? So if you are getting any runtime exception, it is a subclass of which class? Good. Runtime exception class. Runtime exception. If you are getting runtime exception means it's a subclass of which class? Runtime exception class. So very important to remember simple blind rules. If you are getting runtime exception means it's a subclass of runtime exception class and categorized as unchecked. So legal argument exception is a subclass of runtime exception class and categorized as unchecked exceptions. Right? So very important point. This is very, very important during interview times. Right? Then in tomorrow's class, we'll continue with the remaining part of multi-threading, where I'll be taking one more example to elaborate more on multiple threads, how multiple threads are working, how CPU is allocating time for multiple methods that we are going to prove it. Then we'll discuss how to create threads using runnable interface, synchronization concept, and inter-thread communication. So these are topics we'll be discussing in tomorrow's class.